Okie doke. 3.2. Oh, substitution. Yeah, thank you. 3.2 is going to be, again, it's going to be a linear. And how we can tell if something's linear or nonlinear just by looking at the graph, the table, and the equation. Yeah. Just by looking at the graph, the table, and the equation. All right, so as you guessed it, guys, the graph is very straightforward. You're either going to have a straight line or you're going to have a curvy line. That's straightforward. Yes, sir? And we're going to call this one linear and this one non-linear. That's how you're going to be able to tell what's going on just by looking at it. Is it a straight line or not? Linear or not linear? All right, but if they give us a table, we're going to have to do something a little special. This is called common differencing. And the good thing for you is just adding, subtracting. Nothing big, nothing major, just adding and subtracting. All right, so for this example, draw yourself a little rectangle, and this will be a symbol for your room. It could be any room in your house, maybe your living room, dining room, bedroom, whatever you got. Now, your room is probably different size than my room. It's probably different size than your room. It's probably different size than your room, right? So we don't really know these lengths. We just know that everybody is different, and each room kind of looks like that. All right, so let's say we've got a couple of different, we take a measuring tape, and we go from one end of the room to the other, and we say that it's going to be 1 foot. We go to Monte's room, and he's got a bigger crib. We go to Lala's room, he's got a bigger crib. We go to Andrew's room, and we also go to Majority's room. So you got the biggest room of all. So we want to take a look from last chapter test. One of the things that we needed the most amount of work on was called perimeter. Perimeter. What operation are we talking about? Addition, subtraction, multiplication, or division? Addition, good. And so let's get an answer from you over here. What does perimeter mean to you? Is it add, subtract, multiply, or divide? Perimeter. Addition, very good. We got 2 responses for addition. We're going to put that in as our class answer. We need to be using addition for perimeter. My bad. All right. So, Walter, ayúdame por favor. Aquí tenemos X, aquí. So, aquí también. Muy bien. Yeah, I just meant that perimeter is going to use addition. Yeah, good. Y luego, Alan, tenemos 2X aquí. So, si tiene 2X aquí, ¿qué es aquí? 2X está aquí. ¿Qué es eso? 2X. Ya, muy bien. So, adición, ¿no? This is más, adición. Okay, so, we have X más 2X más 2X. ¿Cuántos X tenemos, Angel? Ajá, 2 más 2 más 2. Otra vez, no, está bien. Uno más uno. Más dos. Más dos. Muy bien.
6x.
That's 2x. 2x.
Ah, yes. X. Montre, X is here. X is here. 2x is here. 2x is here. So we have all four sides. We're adding them together. John, if we go in to Lalo's room, which is 1 foot, what is the perimeter of this room? Okay, so we know that it's 6x, and we know that in Lalo's room, x is equal to 1. So when you put a 1 here, what is 6 times 1? 6x. What is 6 times 1? 6. Very good, John. And we'll say feet, right? We'll say 6 feet on that. Cool. Eric, if I have a room that has a length, a side length of 2, let's say Andrew's room, he's got 2 feet for every x. What's his perimeter? Cool, so we're saying 6 times 2, right? 12. Very good, Eric. 12. All right, now let's go to Andrew's room. Andrew has 3 for his x. That's 3 for his x. So, Andrew, if you have 3 in this x, what's the perimeter?
18. Awesome.
We'll keep going. Krishan, if you have a room that has 4 foot on the side, what would your perimeter have to be? All right, that's awesome because 6 times 4 is 24. Edmund,
Do our last one for us, if you would, please, ma'am. If we had a length of 5. Oh, very good.
this gives us our perimeter. I want you to change gears. Switch over to area now.
Oh, very good, very good.
So, Edmund gave us our key point.
For the area, is we're going to use multiplication. In other words, area is length times width. And we'll call this one length and this one width. You guys are rock stars.
Hanging in there. I'm seeing everybody doing notes. Everybody's participating. Thank you. I know it's a big day. A lot going on. Good. So,
Andrew helped us out here. We say area is x times 2x. Very good.
x times 2x. Now let's do this chart that we just made, but let's do it for area now.
So we'll do x and y. Same deal. 1, 2, 3, 4, 5.
And this is our formula, right? We're going to use x times 2x to help us out. So let's put in a 1 of x. Let's put in 1 here. So we're going to have 1 times 2 times 1. So what do you come out with when you multiply 2 times 1? 2. And then if I multiply it again by 1, what's it still? 2. Good. All right, Darwin. Tiene 2. So aquí, cada vez, cada x, cambio con 2. So 2 por 2 por 2. ¿Qué es eso? 2 por 2. 4 por 2. 8. Muy bien. So we get 8 out of this because we have 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. Angel, help us out with 3. If we put a 3 in here, what is 3 times 2? 6. What is 6 times 3? 18. Perfect.
Great, Angel.
All right. Mr. Madrid, Mr. Luis, help us out with x is 4. When you put this into your calculator, what does that say when x is 4? We have 2 times 4 times 4. Yeah. Okay. So 4 times 2 is 8, and then we use 2 times 4. Yeah. Perfect. Luis got 32 for us.
So we're going to put 32 in here.
What? Yes, it is. All right, Edamaris, what's 5? All right, so we have 5 times 2. What's 5 times 2? 10. And then we're going to put this 5 here. What's 5 times 10? Awesome. So let's put in a
50 here. And then let's make sure we got that right. We have area equals 5 times 2 times 5. This is Edamaris' equation, right?
We okay with that? So what was the change we had to do? We multiplied differently. Okay. So we're going to do 2 times 5 and then times 5. Cool. Alright, so now let's talk about common differences. Above this first chart here, guys, you're doing great, by the way. We're almost done with this whole section. You're doing great. But common differences are going to stick with us for the rest of math. Very, very important to know your common difference. Yeah. Yeah, common difference. I'm going to teach it now. Yeah. Yeah. Yeah, and we're going to take each one of these and we're going to go further into it. So this is around 3.2, line down the line, but we're going pretty far into it. All right, so how do I go from 1 to 2? Majority? Aquí es 1 más que es 2. 1 más que es 2. This is not okay. What language can I speak in that can help you?
Well, right now, you're testing while I'm teaching. And I'm asking you what 1 plus 1 is. And you're having a problem. And I'm asking you in a language that you require me to speak in. And I don't really know. And you're still testing me on your phone. Like, I don't know what else to do here to help you out. So, majority, es 1 más 1. Muy bien.
So, 1 más 1 es 2. 2 más que es 3. 2 más 1 es 3. 3 más que es 4. Más 1 es la diferencia aquí. Y también aquí la diferencia es 1. Y es la palabra aquí, diferencia. ¿Ok? So aquí,
This is más 1, más 1, más 1,
más 1.
All right, so down here,
Montre, how would we go from 6 to 12? so we're looking for differences, right? So we're talking add, subtract.
Let's see.
So how do we go from 6 to 12? Good. And what about from 12 to 18, Edamers? Well, 6, John, how do we go from 18 to 24?
Yeah? How much am I adding? All right, and 24 to 30. What do you think, Eric?
How do I go from 24 to 30? Yeah, that's right.
So here's the whole point of the exercise, right?
If you have the same number on the top and the same number
Consistently throughout the bottom, that's how you know this is linear. This is all linear.
So I'm going to label my table here, the parameter,
As linear. Awesome. Do you think the same thing's going to happen with area? And it's still going to be linear?
Nah, because it's one side expands, the other side expands too, right? And expands out.
So let's check it out.
Angel, how do I go from 1 to 2? Okay, how do you go from 1 to 2?
Yeah, that's right. How do we go from 2 to 3? Yep. What about from 3 to 4, John? I know, if you'll take your phone and put it in your pocket, we're going to have a break in a second anyways.
So how do I go from 3 to 4? What do I have to do? I have to add 1, good. And then add 1 again, right? Alright, so let's look at the bottom.
How do we go from 2 to 8, Jennifer?
I need a plus 6. You don't have to make these numbers up, guys. You have an entire answer box.
It's yellow and it's sitting right on your desk. You have all of the answers right in front of you.
Alright, how do we go from 8 to 18, Eric?
How do we go from 8 to 18?
Plus 10? I'm going from 8 to 18. How about 18 to 32?
What do you think, Lala? How do I go from 18 to 32? Yeah,
Plus 18.
and this right here is why this is non-linear.
It's because you don't have a common difference. Here's plus 18, here's plus 10, here's plus 6.
These numbers are all different.
So this is non-linear.
All right, let's do these as a group, as a whole class, and then I'll give you some practices to do in partners or by yourself, okay? All right, take a look at number 1. As a class, what are we thinking? Is this going to be linear or non-linear? Yeah, give me a vote. We're going to say this is linear And we got a bunch of these all together. So when you look at this, linear, non-linear, what do you think? Or, I don't know. Go. Go. All right, good. This is non-linear. We know this is non-linear because this is a curved line. Non-linear. All right, number 2. Up or down? Is this linear or non-linear? What do you think? Yeah, almost there. Everybody all the way across. We're waiting on 1 or 2 folks. Good. Linear. Very good. This is linear. Number 3. Give it a look. Tell me, do you think this is linear? Non-linear. What do you think? Or I don't know. You can do any way you want to go. There's no right or wrong answer, guys. Nobody's going to come by and go, The difference here is +1, +1, +1. What's the difference here? +3, right? -1 to 0, 0 to 1, 1 to 2. So the distance is 3. What's the distance here between 2 and 5? 3. What's the distance here between 5 and 8? Good. This is 1, 1, 1. This is 3, 3, 3. Do we have a common difference? Absolutely. This is linear. Yes, linear. Number 4. What do you think? Linear, non-linear? Take a guess. Not one person is going to come by and be like, suck. No one's going to say that. Just take a guess. All right, cool. Let's take a look. 0 to, or -1 to 0. What's the distance? 1. What's the distance? 1. What's the distance? 1. What about here? What's the distance? Okay, but what's the distance here? From 0 to -1, the distance is -1. Okay, from -1 to 0, the distance is +1. From 0 to 3, the distance is 3. Do we have a common difference? No, these are not in common. This is non-linear. Non-linear. All right, so now let's take a look at just the equation now. Just the equation. Give it a guess. Give it a guess. Do you think this is a straight line or not a straight line? Straight line, not a straight line. What do you think? Good. Almost everybody. Guys, it's okay to make a guess. You can be wrong 100 times. It's fine. I just, I need to know that before the exit ticket so I know what to teach and what not to teach. All right. This is a straight line. Here's what it's going to look like. All right, so we've done graph. We've done table. And now we're going to do equation. This is our last thing in 3.2. You guys are doing great hanging in there. We've got equation. All right, if your exponents of x and y are 1, that's a great way. Yep, if your exponents of x and y are 1, that's huge. And if there's no multiplication or anything, things like this. Great, now that's going to be stuck in my head forever. All right, so a good example of a linear is y equals 3 minus 2x. Right here is what we're looking at. This exponent and this exponent are both 1s. Alright, here's a non-exam. Here's a non-linear. So over here, maybe off to the side, just put non. Alright. So y equals negative 2x squared. Classic. Non-linear. My exponent here is bigger than 1. So that's like, you can just look at it and know the answer. You don't have to do anything. Alright. That's going to be in there really good today. Alright, take another look at 5 and 6. Alright, Mr. Lalo. Number 5 and 6. Is this a straight line or no? No. Okay. What are the exponents of x and y? They're 1, right? There's no number there? So if there's no number there, these are 1. This has to be linear. Look over here. Look at the exponent here. Is that a straight line? Nah. Alright. Pretty okay, right? Like we can see that. This 3, non-linear. This right here, solo x's and y's, linear. Alright, number 1. Oh, 3x this time, not maybe by the class, maybe by yourself. Try these out and now vote for me so I know where you're at. Number 1, is this linear, non-linear? Linear, non-linear. Number 1. I'm waiting on 1, 2, 3, 4, 5 students, please. Waiting on 1 student, just 1 student. Is this linear or non-linear, bud? Okay, so that's what you're going to do, right? You don't even have to say anything. Just give me a thumbs up, thumbs down. Oh, number 2. Linear or non-linear? Yes, non-linear. Non-linear. Number 3. Linear, non-linear. What do you think? Thank you, everybody. Thank you. We need some more help here. How do I go from 0 to 2, Luis? Plus 2, and what about here? And? But what about here? We go 3 plus 6 is 9. How do I get from 9 to 27? Plus a lot more than 6, right? What about from 27 to 81? Plus a lot more than 6, right? Okay, so do we have a common difference? Is it the same number each time like it is on the top? So non-linear. Non-linear. John, this one was non-linear, right? Alright, let's go on to number 4. Alright, take a look. Number 4. Linear or non-linear? What do you think? Number 4. Good. We've already got some people who know what's up. Good. Take a look. We're waiting on 2 more folks. Thank you. Linear, non-linear. Alright, this should be linear. Take a look. 14 to 24. Andrew, how do I go? Plus 10. And then? 10. 10. Alright, common difference up here. How do I go 24 to 20? Minus 4. Do I have a common difference? That's why this is linear. Alright, 5 and 7. Take a look. 5 and 7. Number 5. We got linear or non-linear? What do you think? Linear, non-linear. Number 5. Alright, I'm so glad we pushed through this. Number 5. Linear. And here's why. Here's why. Your x has an exponent of 1. Has an exponent of 1. Your y has an exponent of 1. Everything in here is addition and subtraction. This is linear. Now look at number 7. What operation is hiding in here, Edamaris? What operation is between these two parentheses? Multiplication. Number 7, nonlinear. Because it uses multiply. Try it again. Try it again. Look at number 6. Linear, nonlinear. Number 6. Linear, nonlinear. Good. This is linear. Number 6 is linear. The exponent here is 1, 1, 1. And it's addition. It's addition and subtraction. So this has to be linear. But look at number 8. That's not multiply. It's multiply. This right here means nonlinear. Because of multiplication. When you multiply this x and y together. Okay? We'll do some more examples like that. I'm seeing your faces looking along. Maybe not. Alright guys, we're about to go into the last part of this lesson, so why don't we go ahead and take a break now. I'll put 5 minutes on the thing for you. If you want to take out your phone and do your thing, 5 minutes. Alright, if you need to use the restroom, now's your time. Come on up and go into the crack. Okay. I'm going to save this one for the ladies. They need to go.